Hello. In this video, we're going to cover median and interquartile range. So up to this point, we've been talking about the mean. We've been using the mean to go through and find what we could consider a typical value or the center of the distribution. The mean is the most popular method for going through and finding that quantity, that value. But it's not the only value. The mean has some issues, and the mean is not perfect. So if we go back to the mean, it does a great job on unimodal symmetric distributions. That last bit is really important. It's for unimodal symmetric distributions, the mean works very well. However, if you have a skewed distribution, the mean does not do a good job. So let's just take a look at that. So we mentioned that in the mean video, but let's take another look at that just to kind of reiterate that. Okay, this video has a lot of pictures, and so it's going to be really difficult for me to find them. Hold on. All right, so this is the picture that we went through and looked at back in the mean video. And what it has is it has the winnings in 2018 for the top 100 ranked tennis players. And if you go through and you find the mean is around this arrow here. I think if memory serves, it was like $1.7 million, something like that. And if you think about using that as the, as a typical value, right? The idea behind when we go through and look at distributions, one of the things we ask ourselves is what's normal, what's typical? If you go through and you're studying house prices, and you collect a bunch of data, you want to know what's the normal house price? How much are most people's, like the typical person's house worth? And so when we're looking for typical value, one of the things that we're looking for is, does it make sense within the distribution? And if you go through and look at this as an example, where that arrow is right there, so that ends up being, that's the mean there, and like I said, I think it's about 1.7. I don't remember exactly what it was, but it doesn't really matter. It's about 1.7 million. What's the problem with that as our typical value? Like if you asked somebody, what is the normal amount that a tennis player makes? And if you said, well, a normal tennis player makes $1.7 million, what's the problem with that? The issue is that if you actually go and look at the data itself, this area here that's below that 1.7 has about 75% of the data lies over here, about 75%. So about 75% of players actually make less than the mean, make less than $1.7 million. And so this is a fatal flaw of the mean, is that when you have a skewed distribution like this, where you have like a bunch of entries on one side and then a bunch of outliers over here, like a long right tail off to the side, that right tail is going to pull the mean to the right, because the mean, again, is the balancing point. It's going to pull it to the right, and it's going to make it so that a lot of your observations, a lot of your players are below the mean. And so that's a fatal flaw. The mean does not do a good job of determining a typical value for a skewed distribution like this. You should not use the mean on a skewed distribution like this, because the value that it gives you is not going to do a good job of giving you what's typical, or what's the center of the distribution, which is which is what we're trying to achieve when we go through and use the mean. Let's look at one more picture if I can find it out of the dozens of pictures that I have here for this lecture. is it? Okay, I think this one's it. Okay, so what we've got here is another data set. This has the distributions of annual incomes for New York State residents, a selection of New York State residents. I don't think it's all of them, but and so what's got is its relative frequency, so it's not count. And so what somebody has gone through and done is they've went through and they've calculated the mean for this distribution, and they put an arrow right here at the where the mean is. So that's our mean. If you take a look at that data set, does that, and again, the whole point of calculating the mean is to get us, the typical value, the center, what we think of as representative of normal in the data set. Does it do a good job on this data set? And if you take a look at the underlying data, you've got the relative frequencies here. Think about that arrow. Think about putting a line right there through that arrow. See if I can do this. All right, so that we break up the distribution into the left side of the mean and the right side of the mean. Is there a problem, with going through and putting that the mean at that spot, putting the typical value? So the mean is that spot, but our interest is, does that do a good job of telling us what's normal? And if you look at this with the relative frequency, all of this bar here is to the left of the mean, right? It's to the left of what we're saying is the typical value. And you can actually just look at the relative frequency to see how tall that is. That's almost 70%. So almost 70% of people make less than the mean that's listed here, the 50,334. So almost 70% make less than that. So how can that be a good representative value for what's normal if 70% of the people make less than that? Okay, so think about that. You're going through and you're collecting income data, and someone asks you, what's the normal amount that a person makes in New York? And you say, a normal person makes $50,000, and yet 70% of people make less than that. Okay, it doesn't make sense. So the mean does a bad job of going through and finding the typical value, the center, what's normal. Okay, it does a bad job with skewed distributions, and this is also a skewed distribution. The mean does a great job on unimodal symmetric distribution. So that's critically important. That's when you should use the mean, is when you've got a unimodal symmetric distribution. All right, so getting back to our whiteboard here. Okay, so the mean excellent for finding the typical value, is not excellent, does not do a good job for skewed distributions. So what else could we use? What alternative is there? Enter the median. All right, so so what is the median? The median is the idea of using the middle observation as the typical or center value of the distribution. So what the median does is it goes through and it divides the distribution so that half the observations are above and half are below. Okay, let's look at some examples. Okay, let's see for our first example. So what we've got here is we've got a dot plot for the percentage fat from ham. I believe this is from a grocery store. So somebody went to the grocery store and they went through and they collected the data for the percentage of fat that's in ham. And so they went through, and if you take a look at this distribution here, so you've got some entries here, 20, 22%, 25%, and then you have some really fatty hams over here at, upwards in the 30s, in the low 30s, right? Around 31 and around 33. Okay. And so the median for this distribution is going to be around 23.5%. If someone asked you what's normal for the amount of fat in ham at the grocery store and you had this distribution, would you say that that would be a good estimate? Okay, so just think about that for a second. So you've got 20, a bunch around 22, a bunch around 25, and then a couple of real extreme outliers here way off to the right. Does 23.5% do a good job of determining the typical value? So is that typical? Think about it. So I would say that it is. Okay, so if you've got a bunch of data, 20, 22, 4 at around 22 and 3 around 25, then I would say the typical value should be around 22 to 25. It should be in that vicinity. And so the median ends up doing a great job here of going through and measuring that and determining that. If you had found the mean, so I don't have the mean here, but if you'd found the mean, these two entries up here around 32 and 34, they're going to pull this way to the right. And so the mean suddenly would probably be around 26 or 27, with the vast majority of ham fat content below it. Again, not making sense. So when you've got this skewed distribution where you've got these entries that are far off to the right like this, you don't want to go through and use the mean. The mean does not do a good job. All right, so the median does a good job. Okay, let's try another example here. I think this one is next. All right. So we've got the distribution of incomes for New York State. That's what we were just looking at. And so this time we went through and found the median instead of the mean. Okay. And the median is now around $30,000, right? Recall the mean was around 50,000. And so for 30,000, that tells us that half of the residents of New York State make less than 30,000 and half make more than 30,000. So if someone asked you what's a good measure for what's typical in New York State, and half make less and half make more, then that number 30,000, that does a pretty good job, by going through and using the middle value. Okay, and so where the mean was 50,000 and almost 70% of residents made less than that, the median is 30,000, and you know that half make less and half make more. Okay, and so the typical value, being around the middle of the distribution here at 30,000, that does a much better job at identifying what's normal, what's typical. All right, and so the median is the superior choice for that. Okay, again, this is a skewed distribution. That's why the mean does such a poor job. So one of the things we can also do is we can also go through and look at and compare distributions. So let's take a look at, I think this is the picture. Yes, the pictures are really tiny on my screen, and so it's difficult to tell one from another. So we can go through and we could compare New York State to Florida. So here, Florida, we have someone went through, collected similar data for Florida, they went through and they found the median, and they found that the median was 27,000 in Florida. So we just looked at the median for New York, 30,000, the median for Florida, 27,000. So you can see the similarities between those two in terms of trying to identify, what's typical. What's typical, what's the middle, is fairly similar for the two different places. However, as we will see when we get into interquartile range, just because the two have similar medians doesn't mean that the distributions are necessarily in terms of variation. It doesn't mean that the variation is similar. So just like with mean, that as a determining factor for the center for a unimodal symmetric distribution, we added on to the mean, we added the standard deviation for a measure of variation. So what we're going to do with the median is we're going to tack on interquartile range. And when we do that, you'll see that while Florida and New York have similar medians, they have different variations. Okay. And so that's just interesting, just kind of setting the stage for that by going through and doing the comparison here now between the two distributions. Okay, so the next thing I've got written down here is let's go through and calculate the median. How do you calculate a median? So the middle value, the issue that you run into with the middle value is it depends upon how many observations there are. So there's two different cases that you've got to deal with. If you have an even number of observations and you have an odd number of observations, then the median is a little bit different to calculate. If you have an even number of observations, then that means the middle is going to have two values in the middle, right? So if you've got 8 observations, then the middle is going to be 4 and 5. Whereas if you have, like 5 observations, then the middle is going to be 3. There's only going to be one middle. And so that's the one issue with calculating a median, is there's kind of two cases. However, when you go through and calculate, the first thing you need to do is you need to sort the data from smallest to largest. All right, second, if there's an odd number, then the middle is the median. All right, and then finally, if there is an even number, then the median is the average of the middle two. All right, so let's go ahead and do that. We'll do it by hand, and then we'll go back and I'll show you how to do it with Stack Crunch. Although it's going to be very similar to the way that we did it with Stack Crunch from the mean. It's basically exactly the same. Okay. Let's take a look. I think this is the data set that I want. All right, so yeah, we're going to go through and we're going to do, we got gas station prices. So we already went through and found the mean for this. We want to go through and find the median now. All right, so the first thing you need to do is you need to go through and sort them. So we need to find the smallest. I didn't do this in advance, so hopefully you don't make any mistakes. All right, so 2.17 looks like, so 217. is the smallest. We'll put a little check mark. Then we got 219, 219, 219. All right, what's next? 224, is that what's next? Yep. 227. 229. We've got a bunch of those. 230. This is the part that's time consuming. And then 239, two of those. All right, so hopefully no mistakes there. All right, and so then the median, how many entries we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got an even number. So with an even number, you want to go through and you want to do the middle two. All right. And so the middle two, if we go through and do 12, it's going to be 6 and 7. We got 1, 2, 3, 4, 5, 6, and 7. Right. So you can count them. We got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the middle two is 6 and 7. All right. And then so to go through and calculate the median, once you've got the middle two, you just go through and you average those with an even number of observations. So we've got 227 plus 229 divided by 2 equals 228. So that's the median. All right. So that's how you go through and calculate the median with an even number of observations. All right. I think I've got an example with odd as well. I can find it. All right, here's a case for odd. So these are turkey amounts of fat from sliced turkey amounts of fat, I believe, if memory serves. And so let's go through and find the median for these turkey fat. And so again, you first want to order it, and I didn't do this in advance either. So it looks like 10 is the lowest. Got 1, 2, 3. Oh, there's a fourth. 4. Then 14. And we've got 20, and there's 3 of those. And 40. Then 50. Oops, I had to pause it because I was like, wait, there's an even number here. And that's because I missed a 20. There's actually 4 20s. I've been good if I did 2 even examples. All right. And then so we want the middle. All right. And so now we've got 11, I think, entries. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. To go through and find the middle, you want to add 1 and then divide by 2. So if we go up to 11, add 1 to get to 12, and then divide by 2. You want the 6th entry. 1, 2, 3, 4, 5, 6. And if we did this right, we should have 5 below and 5 above. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, and so that's going to be our median. All right, so again, how did I do that? I went through and I took the number of entries. When you have an odd number of entries, I took it, I added 1. So if you've got n entries, you want to add 1, then divide by 2, and that will get you the median, the entry number for the median. So this will calculate the entry number when they're ordered like this for the median. Okay, and then just to jump back, because I didn't think I explained exactly how I did that with the gasoline example. Let's just jump back to that one real quick. So, what did we do here? We had 12 I went through and I divided by 2 to get 6, and then I added 1. I did 6 and 7. So if you have, if you have 10 entries, then it's going to be 5 and 6. If you've got 100 entries, it's going to be 50 and 51. Okay, so you want to take the number of entries, divide by 2, okay, and that's going to give you the first entry for the median, and the second one's going to be the one after that. Okay, that's going to be the first entry, and then the second entry is going to be the next one. Is the next one after that. So hopefully that helps to figure out exactly what you're doing. Okay. So yeah, so if you had 40 entries, you'd want the 20 and 21st, and you take the average of those two to get the median. Okay, so hopefully that helps in terms of going through and calculating the median. Let's see, did I want to go through and do this now? You know what? I'll show the StatCrunch calculating the median at the end, because we're going to want to have StatCrunch go through and calculate the interquartile range as well for us. So let's just come back to having StatCrunch go through and do this, and we'll just do median and interquartile range all at the same time. All right, let's jump over to the interquartile range. Let's talk about variation next. So we've got a method for going through and finding the center for a skewed distribution. What about an equivalent for standard deviation? And so that's going to be our interquartile range. So that's going to be how we measure variation for a skewed distribution. So what is it? It's the space that the middle 50% of the data occupies. Roughly middle 50%. So what you do is you go through and you cut the distribution into 4 parts that have an equal number of observations, and then the distance between the middle 2 parts is the interquartile range. And I'll post pictures in just a second. It'll make it easier to understand. So what you're going to do is you're going to cut the distribution into 4 equal parts. The distance between the middle 2 is the interquartile range. All right, let's take a look at pictures so you can actually understand what's going on here. I think this is the one I'm supposed to use. All right, so what do we got here? So we have a distribution of weights of students in a class. All right, so these are just a dot plot. Someone's gone through and they've collected a bunch of data on the weights of students, and then they went through and broke up the data into quartiles. So quartile is 25%. So we've got the bottom quartile, 25%, then the second quartile, third quartile, fourth quartile. All right. And they went through and they broke them up. The median is on this graph. All right. So it's right here. The median is the dividing line between the second and third quartile, right? So it's right there. That's the median. All right. What the interquartile range is it's the distance that's taken up by these middle two quartiles. So the interquartile range is going to be, let's see, it's not really, actually, I can go through and edit the picture. Let me go through and do this live. I didn't intend this. Let's see, is this going to be a disaster? All right. So the interquartile range is from here to here. And there's no room to write range. So that's what the interquartile range. It's the space in the data that's taken up by the middle 50%. So to go through and find it, what we would do is we would take this end point of this quartile and this end point of this quartile, and we would go through and we'd subtract the two. So in this particular case, this value here is 160. This value here is 121, which equals 39. So the interquartile range is 39. So we have 39 pounds separates the middle 50% of the students. All right. So it gives us a measure for how much variation there is in the data. All right. And so in terms of just wrapping your mind around, okay, is 39 a lot or a little? I mean, in isolation, it's just like standard deviation, and it's difficult to interpret in isolation. So to try and help us like interpret how you could use interquartile range, what we're going to do is we're going to look at another graph. We're going to look at another picture. All right, so what we've got is the same set of data, but it's broken up into male and female. All right, so it's broken up by sex. And what someone has gone through and done is they've done the same thing. They found the median and they found the interquartile range for women, and they found the median and the interquartile range for men. Okay. And so the thing that's interesting about this is, to help us kind of wrap our head around, how you can interpret the interquartile range is if you go through and look at the difference between these two. All right, so I went through and I just did a rough estimate of this. So this line right here, if you kind of just extend it down to the bottom, it looks like it's at about 115. Okay, so the bottom 25% of women is separated from the next 25% by, looks like 115. And then the median looks like it's at like 125, which doesn't really matter for interquartile ranges. But and then the next 25%, it looks like it's at about 135. And so what we've got is we've got an interquartile range, which we can shorthand as IQR. An IQR for women of, so to find the IQR, you take this value here, which is 135, and you subtract it from this value here, because we want the distance between them, the space that's taken up by the middle 50%. And so 135 minus 115 is about 20 pounds. Okay, so about 20 pounds separates the 25th, actually, let's make this a little simpler. I'm going to go ahead and start referring to these as the quartiles as percentiles, just because it make it a little easier, because I'm kind of struggling to describe it without doing that. All right, so this line right here that separates the bottom 25 from the next 25, this is called the 25th percentile. All right, and so the 25th percentile separates the 0th percentile, which is the very bottom, from the next group. So you got 25% here, and then from 25% to the median is the 50th percentile. All right, that's supposed to be a 50. It's a little hard to read, but all right. And then the next one, we've got this line here. This has 75% is less than that. So this is the 75th percentile. All right. And then if you all went all the way to the end, the 100th percentile is like the last entry. All right. And so we've got, by going through and using the percentiles, then it just makes it a little easier to in terms of language. So what we want for the interquartile range is we want the difference between the 75th percentile and 25th percentile. So you just want to subtract those values. So the 75th percentile is at 135 and the 25th percentile is at 115. That's for women. All right, now for men, we've got the 25th percentile is at 140 and the 75th percentile looks like maybe, what is this, like this is 170, 177 maybe. All right, so we've got the interquartile range is going to be 177 minus 140. All right, and so we get 37 pounds. All right, and so again, the whole point of this exercise and comparing these two is so that we can go through and talk about how do you interpret interquartile range. All right, and so I was just knowing, oh, well, the middle 50% of people are in that range. It's not necessarily helpful in terms of interpreting it. I mean, it kind of gives you some idea. But what works better is to compare two distributions. And so what we can say is that the variation in women in terms of their weight is much smaller than the variation in men, half as much. And so the range for women is 20 pounds from the 25th percentile to the 75th. And then for men, it's double that, it's 37 pounds. So there's much more variation in men, the weight of men, than there is in the weight of women. Which, I mean, you can go through and kind of think about and determine whether that fits, with what you think reality is. And that's kind of one interesting way to determine whether the results are legitimate, is to kind of consider them relative to reality. Is that your experience? All right, and then we went through and did another picture here. Okay, hold on. I think I'm going to have to pause yep, just 1 second. Okay, I did such a good job of finding the pictures, and then finally I just could not find the next one amongst the like dozen pictures I've got here. All right, here's another one. And so one thing about the median, which is an important feature, is that the median handles outliers really well. Okay, unlike the mean can be completely skewed. It can be completely moved by a single outlier. So you go through and you're collecting your information on like housing prices, and you go through a neighborhood and you collect housing prices, and let's say the average housing price in a neighborhood is, I don't know, $300,000, and you've got 100 houses. And then somewhere in the cul-de-sac, there's like a hilltop or something like that. And there's like a hilltop mansion that's worth $20 million. If you find the mean for that neighborhood, the single hilltop mansion that's $20 million is going to take the mean, it's going to take the result for the rest of the houses, and it's just going to completely move it. And so that's the issue with using the balancing point, is a really, really heavy weight that's far from the middle can pull the balancing point so that you end up with a result that doesn't really make sense for the neighborhood. So you could have a neighborhood where the mean without that mansion is like 300,000, and then you throw that in, and then suddenly the mean jumps to like 500,000 or 600,000. And so you're talking to somebody and they're like, what's the typical house price in this neighborhood? And you're like, 600,000. And yet you go through the neighborhood and like nobody's house is worth 600. Like there's just a bunch of houses that are around 300,000, and then there's this $20 million mansion. And so the mean handles outliers extremely poorly. It's a fatal flaw of the mean, is that you need to be very cognizant of outliers when you're going through and using it. Meanwhile, the median does a great job because the middle value, an outlier just counts as just one entry. And so let's say we were going through and doing the men's weights, and then there was this supposed to be a mistake or just someone who, a very lightweight guy? I can't remember exactly what's supposed to be the case here, whether this is supposed to be a mistake where someone made a typo, or it's just someone who's a very lightweight guy. But anyway, if you've got your distribution here, and this is the same one we were just looking at, where you've got 140 is the 25th percentile, 160 is the median, the 50th percentile, and then looks like 177 is the 75th percentile. Same exact distribution. You go through and you add this entry, looks like maybe it's around 97 pounds, and the data barely changes. I'm assuming in this case that the data doesn't change at all. It might change slightly because if you add one entry, if you have like an odd number and you have a middle entry, the middle entry, you have an exact middle entry. And then if you add one more, maybe suddenly you'd have two middle entries and you have to take the average. So they might shift slightly, but they're not going to shift dramatically. To stick with that example that we just used, if you went through and found the median of the home price in a neighborhood where all the homes are around 300,000, and you add a $20 million mansion on a hilltop, the median is going to be around 300,000. Because that $20 million mansion only just counts as just one entry. Okay, and so just wanted to point that out with a data set so you could visually see it. If you add an entry, the median for this particular case, the median doesn't move, the interquartile range doesn't change, nothing changes. And that's not always going to be true. There might be slight changes, but the changes are going to be extremely minor. And so what that means is that in terms of the data set, the median is extremely robust to outliers. It handles outliers very well. That's just a very, very important result to be aware of about the median, is that it's robust when it comes to outliers. What you can do for the mean, if you really, really like using the mean, is what you need to do is you need to remove outliers from the data set. So what you could do is you could stick with your housing price example, with the 300 homes prices around 300,000. What you could do is you just remove the mansion from the data set. The great thing about the median, you don't have to remove anything. It just, the middle entry doesn't change if you just go through and add one more entry. Okay, and so the same is true for interquartile range. All right, and then one more example, if I can find it. Here it is. So the last example, as promised, as we discussed, we can go through and we can take our New York income data set and our Florida income data set, and we can go through and we can compare them. So as we discussed, the median for New York income is about 30,000, and the median for Florida income is about 27,000. So in terms of the, if you want to say the typical value, what the middle of the data set is, those are pretty close. However, if you go through and look at the interquartile ranges, then what you'll find is in New York, you've got 47. So 47 goes through $47,000. Okay, so $47,000 separates the 25th percentile from the 75th percentile. So the middle 50%, if there's $47,000 that separates that. Whereas in Florida, you have $37,000 that separates the bottom 25%, from the 25th percentile from the 75th percentile. Okay, and so just in terms of comparison, what could you say about those two? Like, how would you interpret that result? Is you'd say there's more variation in New York than there is in Florida. So the Florida data, the individuals are closer to the median. All right, the incomes are closer to the median. So we said that the median is 27,000. They cluster closer to that 27,000 in Florida than they do in New York, where we've got a median is 30,000, but because the interquartile range is larger, there's more variation in the data. There's more people who make far from that 30,000. Okay, and so that's one of the neat things you can do with interquartile ranges. You can go through and you can compare it between two data sets, and it enables you to say something about how much variation there is in the data, how much entries in the data differ from the median, how far they are from the median. And so it does enable us to do something very similar than what we can do with mean and standard deviation. Okay. All right, and so the last thing we need to do is go through and calculate the interquartile range. All right, how do we calculate the interquartile range? All right, so step one, you need to find the median. This assumes that you've, in finding the median, this assumes you sort the data. Okay, so you need to have the data sorted. All right, so you're going to find the median. Right, so this is the middle entry that's going to divide the data into two piles. And this may come up, in homework assignments. Well, we're gonna label it with Q2. So it's the end point of the second quartile. That's also the same thing as the 50th percentile. I would have rather they had gone through and done percentiles for this and done this. I think we're going to do that later in the course. We'll use percentiles and we'll label them with a subscript. I think I would have liked that better. But I'm sticking with what's in the textbook. So that's the information from this course comes out of a textbook. And so that's what we're doing. All right, anyway, so we've gone through and we've divided the observations into two piles. What you next want to do is you want to go through and find the median of the lower half, the lower pile. Okay. All right, and then if the number of total observations is odd, then you want to exclude the median. You want to exclude the original median, the median of the entire, of all the observations from the lower half. So this is odd. You want to exclude. Okay, so we'll do an example. So you'll get to see, if that's a little confusing, you'll get to see that in action. And then 3, you just want to repeat for the upper half. So you just want to repeat this step 2, including this part with the excluding the median of all the observations. All right. So let's see here. We're going to do a couple examples. We'll do this by hand, and then last I'll go through and I'll bring up StatCrunch and we can take a look. Have the program do it for us. Okay. So here's our first example. And what we have here is these are the heights of children. The book actually has a picture, which I thought about including, but then I was lazy and decided not to. All right. So what we want to do is we want to go through, and we're calculating the interquartile range. The first thing you need to do is you need to order the data. Look at that. It's already ordered for us. It's very kind of them. Okay. The next thing that we need to do is we need to go through and find the median. All right. So the median. So that's if we've got 8 entries, right? 1, 2, 3, 4, 5, 6, 7, 8. We've got an even number of entries. To go through and find the median, take 8 divided by 2. That's going to give you 4. And then you want the middle between 4 and 5. All right. So we got 1, 2, 3, 4, and 5. So we want the middle between these two. All right. And so you average those two. And you can just take 53.5, add 54, divide by 2. You're going to get 53.75. All right. So that's the median. Or Q2, or as I prefer, the 50th percentile. All right. So our goal here is to calculate the interquartile range, not to calculate the median. So we still have to do that. For the interquartile range, what you're going to do is you're going to go through, and the median here, 53.75. If you were to go through and kind of draw a line in the data where that is, so it's between these two, right? So we draw a line there. What the median has done is it's divide this into 2 piles. All right, so we've got our lower pile and our lower half, and we've got our upper pile, our upper half. And what you want to do is you just want to do the median calculation again, but you want to do it on the lower half. All right, so if we go through and do the calculation on the lower half here, we've got 4 entries. You take 4, divide by 2, you get 2 and 3. So that's going to be the middle 2 are these two. All right, and then we can break out a calculator to go through and find the average of those two. All right, let's try that again. All right, so we've got 48 plus 53 divided by 2. So that's going to be 50.5. Actually, I could have just written that on here, right? So we're taking 48 plus 53 divided by 2. All right, and I went through and did that, and I got 50.5. Not 50.2. I don't know why I said that. 50.5. All right, and so this is labeled as Q1. All right, that's the end of the first quartile, or as I prefer, the 25th percentile, P little 25. All right, and so we now need to go through and find the median of the top group here. So that's going to be, so we've got 4 entries. So you want to take the middle 2, that's 60 and 62. We've got 60 plus 62 over 2, right? And we can average this in our head, I think, 61. Okay, that's going to be, we label that Q3 or P75. And then once you've got the 25th percentile and the 75th percentile, you just subtract them. All right, and so the interquartile range is going to be 61 minus 50.5. Was that 10.5? So we get 10.5 is the interquartile range. So that's how you go through and do it. So you find the median of the entire data set, that divides it into 2 piles, then find the median of each of the 2 piles that are left. That the first one is going to be the 25th percentile, the second one is going to be the 75th percentile, and then subtract those two, and that'll give you the interquartile range. Actually, I didn't, there's some details on there that I forgot to include on my my list of steps here. All right, so find the median in the lower half. This is Q1 comma P75. or P75. Oh my gosh. P25. Find the median for the upper half. That's going to be Q3, comma P75. And then I forgot to put step 4 here, where you have to subtract the 2. So we've got Q3 minus Q1, and that gives us the interquartile range. Okay, so yeah, those little details there that I forgot to include. Okay, so that gives us that's the interquartile range calculation for that example. And then I was gonna do one with an odd number of entries. Oh yeah, I remember. Okay, I was gonna use the sliced turkey, the turkey fat example. All right, so here's the turkey fat example, right? We went through and we ordered and we found the median. So how would we go through and find the interquartile range for this? So once you've gone through and you found the median is the dividing line. All right, so we've got a dividing line right there at the median. This is going to split the 2 into 2 separate groups. All right, and so our instructions say to when you're going through and calculate, and we want to find the median for each of these 2 groups. And when you do that, the instructions say we want to ignore the median of the full set. You want to ignore it when you're calculating the median for the smaller sets. So what we want to do here is we want to go through. Can I do this? We want to go through and find the median for that group. We want to ignore the median for the entire set, and we want to find the median for this group. And again, ignore the middle value. So when you've got an odd number of entries and you're going through and you're using the median, breaking it up, you want to go through and you want to ignore the median from the larger data set when it comes to calculating the medians for the smaller data sets. All right. So when it comes to doing the median for this smaller data set here, for the lower half, the lower pile, we've got an odd number of entries, and we just want the middle one. So this guy right here, that's going to be our Q1, or our 25th percentile. And for the top half, we've got the middle entry is going to be this guy. That's going to be Q3, or the 75th percentile. And thus the interquartile range for this data set is 20 minus 10, which equals 10. Okay. Now, if we'd had an even number of entries here, then we would have gone through and averaged the middle 2. If we'd had an even number here, we would have gone through and we would have averaged the middle 2. All right. So you could have an odd number for the total number of observations that when you divide it in 2, you end up with even piles instead of odd piles. All right. How's that possible? I mean, so we had 11 entries here. When you go through and you take 11 entries and you remove 1, you get 10, and you divide it, you get 2 piles of 5. If we'd had 13 entries, and we'd removed the middle, then we would have had 12, and you would have had 2 piles of 6. All right, and then we would have had to take an average of the middle 2 to get the median. Okay, so anyway, that's how you go through and calculate the interquartile range when you've got an odd number. You find the median. That's going to divide the 2 data sets and exclude that from both of the 2 data sets when you're going through and finding the median to find the 25th percentile and the 75th percentile. Okay, so that's how you go through and do it by hand. I wouldn't recommend doing it by hand, unless you got a very small number of entries or you just think it's fun. Normally what you're going to do is you're going to go through and have a program do this for you. So let's see, can I find the program? Hold on. Okay, I found it. Geez. It is hard to find these little windows in Zoom when you've got, like 20 of them open. All right, so what we've got here is we've got StatCrunch. We've got the entries for the gasoline, the cost of gas, that data set. I just went through and just plugged them in a single column like this, just like we did when we calculated the mean and the standard deviation. All right, so just did the exact same thing. Once you've got the data entered into a column like this, you just want to go to Stat, Summary Stats. Okay, hold on. Columns. Select the column where the data is that you want to go through and do the calculations, and then just hit compute. Right, and when you do that, so this is the same thing that we did when we found the mean and the standard deviation. It's just ignore that stuff. Just look over to look further to the right. We've got the median is right there. We'll talk about range in just a second. We've got Q1 and Q3. So good thing I did talk about Q1 and Q3 instead of just using the percentiles, because the program is using Q1 and Q3. All right, so anyway, we've got Q1 and Q3. If you want to go through and find the interquartile range, you see it's not there. But to find the interquartile range, you can just take Q3 minus Q1. Okay, so it's going to be 10.5 cents. All right, so if you take Q3 minus Q1, you can get the interquartile range for the when you use the program. Okay, so you can use the program, it'll get you the median, it'll get you the Q1 and Q3 value, and then to get the interquartile range, you just do a quick little subtraction there. All right, that's not the only data set that I went through and loaded. I also went through and loaded this is the air temperature in San Francisco and Provo. This is from the mean standard deviation video. I just wanted to go through and look at the difference between median and interquartile range for those. So, I kind of just skipped over that because I think I've done it enough times. But so once you've got the data well, I guess in this case, I just pulled up the data set. But if you've got the data entered into columns, you just go to Stat, Summary Stats, Columns. You want to select the two columns. You might need to use Shift to select the two. Once you've got them selected, you can just hit Compute. And so, we already went through and talked about the mean and the standard deviation. So you can see the difference between the standard deviation there. But check out, this is kind of cool. So there's other data here. So you got median, look how close the medians are. So the medians in San Francisco and Provo are still really close, just like the means are. That's kind of cool. And then you can see the difference between the quartiles, right? So just to interpret this, what you've got is, what this says that in San Francisco, the difference between the 25th percentile day and the 75th percentile day is about 11 degrees, which is really small. If you went through and looked at lots of different cities throughout the United States, that's probably one of the smallest interquartile ranges to only have 11 degree difference between the 25th and the 75th percentile in a place. That's amazing. So what that tells you is that the temperature in San Francisco has very little variation. There's almost no variation. It's like this temperature day after day after day is very similar in San Francisco. Meanwhile, look at Provo. So you've got the 25th percentile is 50 and the 75th percentile is 87. There's a 37 degree range over which the middle 50% of the data occurs, which is what, 37? It's more than 3 times the amount that there is in San Francisco. And so that just gives you some notion of how to go through and kind of interpret those interquartile ranges. The best way to interpret them is, by comparing 2 different data sets. That's probably the easiest way. And so, yep, that's how to go through and calculate the median and the interquartile range by using StatCrunch. Same way that you did, same way that you found the mean and the standard deviation from StatCrunch. All right, and then we're almost done. The last thing that we're going to talk about is the range. mainly covering it for completeness. I never use the range. But the range is just another measure of variability. I would say a very bad one, but I guess it could be useful, but I'm highly skeptical of the range. All right, so what is the range? The range is the distance between the maximum value and the minimum value. Um, yeah, so I don't really have a lot more to say about it other than just what the definition is. You know, if obviously outliers would have a massive effect on the range and completely throw off any ability for the range to measure variability. It just would tell you, oh, well, there's outliers. So you could have, in our example with the neighborhood that has all the homes around 300,000 and the $20 million mansion, you go through and calculate the range, and you're going to have that $20 million mansion minus those $300,000 homes. The range is just going to be enormous. Meanwhile, the range for the homes themselves could be very tightly knit. The homes could be very close to $300,000 in value, and it could be just completely thrown off. You could get an enormous range when the actual variation of the data itself is actually not that high, excluding the outlier. And so the interquartile range would do a great job of capturing that. The range itself does not. So I would say that this measure is borderline useless, but it's something you can do. You can go through and take the largest observation and the smallest observation, and you can subtract them, and you can get the distance between them. But if you've got a lot of data, I don't know that that's really gets you anything. But anyway, it's there. So we've defined it. So if it does kind of come up in in homework or other places, you do know what it is. All right, so that's going to cover the video for this for today. Thank you so much for watching. See you next time.